Hello dear students, you must be engaged yourself for the preparation of your annual examinations as well as for your competitive examinations. Today we are going to discuss about the magnetic effect of the current, or in your other books you will find that the moving charges and the magnetism of part 4. So, before your part 4, let us recapitulate your knowledge what we already discussed in the part 1, part 2 and the part 3. This chapter deals with the magnetic effect of the current, means while the current is flowing through a conductor, it will be producing the magnetic field. If a field is there, there must be a force, there must be some directions, and what will be the magnitude of that force and what the direction of that force. About that we know by using your right hand thumb rule, right hand palm rule. Likewise, the different actions which we will make by taking the hand positions, means right hand thumb rule, right hand palm rule, right hand rule, means take your bottom thumb and rotate your the four fingers, the direction in which the thumb will direct or the four fingers will direct or the thumb or the palm will direct, that will give you the different concepts of that field. So, today we are going to discuss about your the two things which probably the last part of the magnetic effect of the electric current. The first one is the torque or the couple due to rotation of the rectangular current carrying conductor, and the second one is your the moving coil galvanometer, which you will found very simply it is as the MCG. M stands for the moving, C stands for the coil, G stands for the galvanometer. And what are its the conversions, how it will make to change from your the galvanometer to ammeter or the galvanometer into your the voltmeter. So, let us start from today that the torque or the couple due to the rotation of your the or the due to the current flow through your the rectangular conductor when placed in a uniform magnetic field. So, let me know from you, or just you will think it, what do you mean by the torque or the couple? Do you heard the word of the couple? Couple. So, when the word couple comes, C-O-U-P-L-E, couple, either you do not know or that is you are quite familiar with you, that nowadays when invitation cards will come to your the home, then you will find that at the middle portion it being written that your presence is kindly solicited to bless the newly married couple. So, newly married couple means in our ODIA language that is called your the dampati, means one is the boy, another one is the girl. So, when the boy and the girl both are of your the opposite. So, when the two opposite things of your the different concepts as we are thinking nowadays, but actually they are of the same nature with its the different characters. Means suppose you will have a boy which is a fat one and a girl if that is a thin one, then generally we will not accept it as a good couple. We will say that it is a couple because one boy, one girl is there, but it is not a good couple. So, a couple can be balanced by using our the another couple that you know very well. In your the film society you know that portions are your the good couple. Suppose you will go for the ODIA pictures. In the ODIA pictures nowadays, suppose you will take your the Vijaya Mahanti, suppose you will take with the Tandra Rai, suppose the Uttam Mahanti with your the Aparajita, and nowadays the new heroes those who are coming, suppose one will say Sabyasachi, which is the current affairs. So, Sabyasachi if you will take into account. So, the couple will be very better and they becomes from the real life to the real life with your the Archita. So, they are the couples we are saying generally that is the good couple. Suppose you will go for the Hindi films that are also couple. So, here the question comes, what it couple and what the couple being makes. Suppose I have this one. So, due to the couple it produces here the rotation. Suppose this is a pen which I have taken in my fingers. If I will put a force either at this end or at this end, you will find that it start to your the rotate. So, actually you are looking that a force is acting, but this side is going down, but automatically at the same time the another side is going up. So, when the two forces are to be act, this is my acting force and this is the automatical force. So, this force, these two forces, when they are acting on the same line of action within the different directions, then that will make to the rotate. Suppose with the same one, I will put a force here and another one will put a force here. These two forces of the same nature, means its magnitude is same, but both are to be directed in the opposite direction, then it will never rotate. Suppose you will just pull the force by using the force on the two sides, then that will not the rotate, either that will expand or that will break down. So, here the question is, if a rectangular conductor is to be placed in a uniform magnetic field, it automatically start to rotate, that being developed by the human being. So, today we are going to find out the torque, which in the physics there is a symbol known as the tau, torque or couple due to a rectangular current carrying conductor in a uniform magnetic field. In a uniform magnetic field. For this we are going to discuss. So, let us have a rectangular current carrying conductor, let its name is the PQRS, because this A and B that will come in our notation, PQRS. It being placed this is the magnetic field. So, magnetic field notation we know B, therefore, if you will write it is A, B, C, D, then there is a confusion of this name B and with this B. So, PQRS, let this one is of the small b size and this one is of the L size, and some current is flowing through it. Suppose the current is flowing through it, that current is the I. So, when the current will flow through the rectangular conductor, it will start to the rotate that one, and how that is possible, let us now discuss about that one. So, before going to that one, if you will recapitulate your knowledge, if a current carrying conductor will produce the magnetic field, then the force is equals to the BIL sin theta, or that is equals to the I of the L cross B. That you know, it is in the vector form, this is in its the scalar form. So, if F is equals to BIL sin theta, that is the force, L is the length of the conductor, I is the current which is flowing through it, and B is the magnetic field which it produces with the induction as the B, and theta is the angle between the L and the B, then the magnitude of the force is the BIL sin theta. So, here if you will go for this figure, you will have the four conductors of the shape. If you only say one is the PQ, one is the QRRSSP, or the PSSRRQQP. If you will go for the first one, for arm PS, suppose you will go for the arm PS, you see this PS, this is the arm of length is the L. If this is of the length L and this is the magnetic field, the L and the B, they are making the angle of the 90 degree. So, the force means the force due to the PS, if that is the F1, then F1 according to this formula BIL sin theta. So, B is the B, I is the I, L means the length, that length we already taken is the L also here, then sine 90, that is equals to the BIL into 1. So, that is equals to the BIL. Suppose you will just change its the name, instead of the L that is the B, and instead of the B this is your the L. If you will take, then this BIL sin theta, which is the formula, that will be your the BIB sin theta. So, that is equals to your the BIB, or this can be written as your the this one. For the arm SR, if the force is your the F2, because this is the conductor of a length of your the L and of your the S2, F2, then what will be this one? For the SR, same formula, B is the B, I is the I, because the same current is flowing, L is the length, but here the length is also your the L of your the sine 90, means here theta is the angle. So, what is the theta? It is the angle between L and the B. You see the length is in this direction, the B is also in the same direction. So, theta is equals to the 0. So, this is equals to 0, means this total factor is equals to 0. Sin 0 is equals to 0, BIL into 0 is equals to 0. For arm RQ, if that force is your the F3, so this is your the RQ, then according to the formula BIB of sine 90, that is equals to also your the BIB or the IBB. And for the arm QP, for the arm QP, then if the force is your the F4, you see QP means this is your the QP means the length of the conductor, and this is your the B, they are making the angle of the 180. So, that is also again BIB of sine 180, that is equals to your the BIL of 0 is equals to 0. So, out of the 4 arms, there are the 4 forces F1, F2, F3 and your the F4. You see, your F1 is your the IBB, F3 is your the IBB, means on this conductor, the forces which are acting, if this one is your the F1 and this force to be your the act as your the F3. So, this is the direction of your the force. According to your the right hand rules you can take. So, if this is your the F1 and this is the F3, only these 2 forces are your the existing, other 2 forces are your the 0. Therefore, the force is equals to your the IBB. So, this is an interesting one. The force is equals to your the IBB, but as myself is giving you the explanation about that one, then I am saying that how I will be the IBB. You see, IBB, BB means you know that is a woman. So, can myself will be the woman, myself is the man. So, therefore, it is the IBB. If myself is the man, then I can convert this BB into the man, and you can also convert this BB into the man. So, if this is the force which are acting at diametrically opposite ends, then this will start to your the rotate. So, when that will start to your the rotate, then that will produce your the torque. So, what is the definition of the torque? Torque is the force into perpendicular distance, that is the force into perpendicular distance. So, what is the force here? Force is your the IBB into perpendicular distance, that perpendicular distance between your the that 2 forces. You see, one force is acting in this way, another force is acting in this way. So, what is the perpendicular distance between these 2 forces? That is your the L. So, this perpendicular distance is equals to your the L. So, this becomes your the I capital B of the B cross L I have taken. So, B is your the breadth, if L is your the length. So, length into breadth will be how much? That is the area. So, that is equals to your the I B into capital A. So, this capital A is its the area. area of which one? Area of that coil. So, if I be a, so on previous I am saying that the F is equals to I B B, means myself is B B. I said that myself is never to be B B, myself must be a man. So, if myself is a man, now I converted that B B into the man. You see, now I will say that the torque is equals to the I B A, B A means the ba means a Purusha. So, I B A, now the B B now becomes here the ba. So, in your the creation of the God, we have considered for one time for your the omens, now we consider for your the mens. So, this is your the net torque which is acting on this rectangular current carrying conductor of your the IB. Instead of taking your the one coil, if the number of the coils are there, if number of turns are there, number of turns are there, then what will say? If that number of turns is equals to your the n, now this tau is equals to your the IBA into n, means myself now becomes your the ban, means I never gone to your the man, I never gone to your the woman, so now I becomes your the man. Ban. So, IBAN, this you can remember very easily if you will arrange these words as in this way, means tau is equals to the BINA, just reshuffle the words BINA, that means that is your the Bina which is taken by your the Ma Saraswati. So, if you remember Ma Saraswati and the instrument which is with the Ma Saraswati, that is nothing but in the physics, that is the tau. Okay. As we came to know that the torque which is acting on your the rectangular one tau is equals to your the BINA. So, this torque tau can also be expressed in terms of your the dipole moment, means for the magnetic dipole moment. So, we came to know tau is equals to your the BINA, but this INA that is equals to your the capital M of your the B. So, that is your the MB, means the tau is equals to your the MB, and because you know that dipole moment capital M is equals to your the I. So, this is the vector form, M vector is equals to your the I of your the A vector. So, in magnitude this M is equals to your the IA. Here the n is there, means when the number of turns is there, then that number of turns will constitute the value of the I. So, for the number of turns, the total current is your the Ni of your the A. So, NIA is equals to your the M. So, tau is equals to your the MB. So, there is also another thing. Instead of taking in your the uniform magnetic field of your the in that position, suppose one will take making some your the angle. This is your the magnetic field. So, this is your the B, P, Q, R, S we have taken, P, Q, R, S. So, if they are making some angle, means with this plane of the paper, if this coil is making your the certain angles, means if the magnetic field is here, then the force will be in this direction. This force will be in this direction. If this is the magnetic one, this force is in this direction, and another this is your the magnetic field in this direction, means the force will be in this direction. For the PQ we have taken for the arm PQ, that is your the F1. For your the PQ we have taken F4. So, this is your the F4, this is your the F3, this is your the F2, and this one will be your the F1. You see F2 and your the F4, they are acting on the same line of action. So, the value of the F2 and the F4, they are acting equal in opposite direction. So, that could be your the cancel, and the next remaining is your the F1 and your the F3. Their magnitudes are also same. If we will go for your the F1 is equals to your the IBB, but when they are making the angle of your the theta, that IBB means this side means this one will have its the horizontal component, that is your the L, means this of the length will have your the cos theta factor. Therefore, this will be your the IBB factor or BIL factor, whatever you will take. Either this is your the L or this is your the B, that will have its the component of the horizontal component. If we take the B, then that will be your the B cos theta. If we take the L, then that is your the L cos theta. So, either BIB cos theta or your the BIL of your the cos theta. Therefore, if we will go on the same way, you will find that the tau is equals to BINA with your the that factor of your the cos theta. If you are making it say the angle which is the normal one, that will convert it to your the sin theta. So, this BIL one will be your the MBB of your the sin theta. So, MBB sin theta means M vector cross a B vector. So, this tau vector will be your the M vector cross B vector. This is for your the torque acting on your the rectangular current carrying conductor when it being your the inclined. This inclining angle is your the theta. Here also it is the making the inclining angle, but the current direction we have taken in this way. So, here the force is in this direction. So, the angle theta, this is already the theta. The angle between the length and the vector will be this one. So, here we have to take in here the 180 minus theta. Though we have taken this is the sin theta, that sin theta factor here it will be the sin 180 minus theta, and here it will be the sin theta. So, in both the cases there is a factor of your the sin theta. So, tau vector is equals to your the M vector cross of your the B vector. So, this is about your the magnitude of your the torque which is produced due to the rotation of your the rectangular conductor. By taking these expressions, now we will discuss one or the two of the problems. So, on my last classes I said repeatedly that whenever a problem will be provided to you, you will follow the Pandava formula. According to the Pandava formula, what are the steps you know very well? There are the 5 steps, 1, 2, 3, 4, 5. If a problem is given, you just go through the problem and find it's the 5 steps, and on your the screen now you are finding that there is a problem. So, what that problem is providing, just look after it. A vertical rectangular loop of the sides 5 centimeter and the 2 centimeter. Vertical rectangular loop, suppose this is your the vertical rectangular loop of the sides 5 centimeter and your the 2 centimeters. This is given. So, 5 centimeters and 2 centimeters means if you will take length is equals to L is equals to the 5 centimeter, then your the breadth will be your the B is equals to your the 2 centimeter. 5 centimeter 2 centimeter carries a current of your the 2 ampere. So, current that is equals to the I of your the 2 ampere, current of the 2 ampere. Calculate the torque acting on the loop when it is placed in a uniform magnetic field. So, magnetic field, uniform magnetic field means B, that is equals to the 0.1 Tesla. So, the first step is go through the questions. The question is in front of you. You go through it by making the pause to once or the twice or the thrice. The second step is the write the data. These are the data. The third step is the what to be the asking. The asking is the find the torque. In the question it asks find the torque. So, torque is the tau, that is the question mark. The fourth step is the Akshay Kumar, which is your the sabse bada khiladi. So, you see all the provided data must be same unit. You see this is the centimeter, these are your the ESU system or EMU in the magnetic means your the CGS1. and this ampere and the Tesla, they are in the M case one. So this CGS, either you will convert it to the M case, all to be becomes your the M case, or this M case to be converted to your the CGS, means all to be become your the CGS. That is your choice, which will you will say. What is the rate of this pen? One can say it is the 2 rupees, or one can say this is your the 200 paise. Both are your the same value. So the choice is here, either you will take for the M case and the CGS. If you will ask me, then I will say that you always choose for your the M case, because the M case is the shorter magnitude. Therefore the CGS to be the converted to M case means this centimeter to be converted to your the M case. So this 5 centimeter means that is equals to 0.05 meter, because 5 by 100 it becomes your the centimeter to your the meter. So it was your the 5 centimeter, this is the this meter, this is the 0.02 meter, this is the 2 ampere, and this is the Tesla. Next we have to put the fifth step. Fifth step is the put the formula, get the answer. So what the answer, what is the formula here? You have to find the torque. So torque formula, tau is equals to your the BINA, that we know. So you see I is given, that is equals to the 2 ampere, and the number of turns is not provided here, only the vertical rectangular loop is only given, means N is equals to your the 1. Then comes here the A means the area. Length breadth is given, though the name is the rectangular one. For the rectangular, if the length breadth are given, then the area will be its the product. So now we know, you will write as for the answer, we know tau is equals to your the BINA, Bina. So B is the magnetic induction, 0.1 into I is the current is equals to the 2 ampere, N is the number of turns, only 1, A means your the area means your the length into your the breadth. So length is equals to 0.05, breadth is equals to 0.02. So this is equals to your the 1. So if we multiply 2 into 1 is equals to your the 0.2, and this is equals to 0.05 into 2 means the 10. There are the 4 places. So this is equals to your the 0.001. So this is equals to 2 by 10, and this is equals to your the 1 by your the 10 to the power of 3. So that is equals to your the 2 into 10 to the power of minus 4. So this is equals to your the tau. Tau means your the Newton into meter, because tau is equals to your the force into perpendicular distance. Force means your the F is the Newton, and perpendicular distance is equals to your the meter. So this is your the answer of that one. So whenever a problem will come, kindly follow these 5 steps and you can solve it very easily. Okay. Now we are going to discuss about one of the device which is being developed by the human being, and that device name is your the galvanometer. Probably my students, you heard the name of the some different devices like your the voltmeter, ammeter, speedometer, likewise your the different instruments you know. So this is one of that one which is called your the moving coil galvanometer. Means what do you mean by the first the galvanometer? If the question of the ammeter is comes to your the mind, and you are thinking that the ammeter means it is a device which is going to measure your the current. For the voltmeter, it is that type of device which is going to measure your the potential difference, means it is in terms of the volt, therefore it is called your the voltmeter. Another device you know in your the plus 2 level also, that is your the voltmeter. In your the Faraday's laws of electrolysis, you know that is a voltmeter which is used to measure your the current. Voltmeter, the name stands from the volt, but it is not measure your the potential difference, it is your the current. And here it is the galvanometer. So what is a galvanometer? About that one we will first discuss. So galvanometer, it is that device, it is galvanometer, a device which is used to measure current. Generally we will say to measure current, and for most approximation, that is to measure your the small current. When the large current to be your the measure, then that one is your the ammeter. and there is another word that is your the ammeter, and the students are making in the dilemma. Suppose one will ask what is the difference between the ammeter and the emitter, so they are never you are answering to that one. So emitter, it is a part, emit means bahariba. So the electrode which are just leaving your the particles, then that is your the emitter. So that is your the ammeter, that is for the large current. And this galvanometer is generally of your the two types. One is your the moving coil galvanometer, and another one is a moving magnet galvanometer. So according to your the syllabus, we are going to discuss about your the moving coil galvanometer. Means it is that device in which if a coil to be your the move, then that is your the moving coil. If the magnet to be your the move, then that is your the moving magnet. But in your the syllabus, that is the moving coil galvanometer, which will say as your the MCG, means moving coil galvanometer. So if a device is there, it must work by using some principle. And what is the principle here? When a rectangular coil carrying conductor, is placed in a uniform magnetic field, will start to rotate, or deflect, we will discuss. So about which we discuss now, that if a rectangular current carrying conductor to be placed in a uniform magnetic field, it start to your the rotate, that is its the principle. So after the principle, we will take its the diagram, how that galvanometer is being constructed. So next we will go for its the construction. This is a rectangular current carrying coil. Coil means it has your the number of turns. That being placed in a highly magnetic field. This is the north and the south. This is most probably of your the horseshoe magnet. So due to the horseshoe magnet, these two ends are connected with these two ends. So both are your the concave in your the nature, like your the horseshoe, Ashwa Khurakuti. So this is your the horseshoe magnet with the poles north and your the south. This is the coil, and it being, though it is inside this one, means inside your the magnetic field there is a magnetic induction, and this is your the spring. And you see, this is your the mirror, this is your the mirror arrangement. There is a mirror with some pointer inside that one. Here a pointer is there, and this end being your the connected to the two terminals, this one with your the one terminal, and this end with your the another terminal where the current to be your the insert. If the current to your the insert through this one, it will start to your the rotate. About by taking that principle, this construction being your the made and the working to be your the discuss. So next we will go for its the working. So this spring means this is your the very small wire that is made of your the phosphorus bronze. This suspension wire is made of your the phosphorus bronze. Phosphorus bronze is the very fine arrangement of the wires, because due to the fine arrangement with its the lighter weight, if some current, means if a teeny amount of the current, very small amount of the current will pass, then it will make its the rotation. Likewise, if you will tie with a substance with a stronger wire, if that amount of the force, unless it being acted upon that one, it never to be the rotate. If a very fine wire is connected with a substance, if a small force to be the acted, then that will start to the rotate. That is the basic principle. And here the suspension wire being of the made of the phosphorus bronze, due to its the lighter weight, it can the rotate very easily. So though this is the current carrying conductor being placed in a magnetic field, if the current will pass through that one, according to our the previous discussion, we know that that coil will start to rotate. So this coil, if the current will pass through that one, then it will start to rotate. Though this is the suspension end, this is its the another end. At this another end, the superintendent of police is there. You see the SP is there. When the SP is there, if we will look for the SP, then we will again comes to the same position, because either the police will craft you. Therefore, this SP means not the superintendent of police here, this SP is the spring. Here we have given a spring. What is the nature of the spring? Spring is that nature, if some force being acted, then it to be the deflate, and when that force being taken out, it comes to its the original position. So when this current will flow through this one, then it will start to the rotate. So due to its the rotation, the pointer which is given here, that pointer will give its the indication. The indication is to be measured on your the mirror. There is a glass. So through that glass, you will find that there is a deflection, like your the ammeter or the voltmeter, or generally in case of your the speedometers which is connected with your the vehicles, then you will find that if you make your the more acceleration, there is a indication of that your the pointer. That pointer, if it looks for your at the position of the 20, it will go to your the 60, means we are saying that our vehicle is moving with the 60 km/h. So here also this pointer means due to its the rotation, this pointer to be the deflate, and that deflection will indicates that the current is the flowing, but what is the amount of that current, we will find out by using our the principle. So what is the principle? When the current will flow through that one, it will start to the deflate. Due to the deflection, it will produce a torque. Okay. So torque means that is the couple. So a couple is the produce. So when the couple is producing here, at the another end, what is present? The spring. What is the nature of the spring? It will try to restore its the position. Means from where it being deflected, the spring always try to make it to its the original position. So that original position, we will say that that is your the restore. Re means again, store means where that was. Where that was means initially it was here. When the current is flowing, there is a deflection, means this spring is to be the rotate, and its nature is to keep it to its the original position. Again that spring will comes out. So the question is, if a heavy current will flow through that one, then what will happen? When the heavy current will flow, then this spring will the deflect more. So when the spring will deflect more, there is a chance of your the disconnection. Likewise, in your the self adjustment doors, suppose the door is there, just you will push and you enter. Without saying anything, that door is again coming to its original position, because there is a spring arrangement is here. If that door being the made with the high force, then after 2 to 3 times, then that spring will the cut out. Therefore, this spring will start will make to its the restore. So this torque is the couple. So this couple is to be now balanced by using your the another couple. Therefore, we will say that the deflecting couple is equals to your the restoring couple. So my method is, if just you remember DC and your the RC, then your the moving coil galvanometer is your the over. So DC means your the deflecting couple, RC is your the restoring couple. If the deflecting couple means the couple through which it is being deflected, that is equals to your the BINA. Another one is the restoring couple. That restoring couple here, that is the C theta. So what is your the C? C means your the couple per unit twist. Couple per unit twist means the couple which produced due to your the unit twist, means for your the one twist, if the couple produced here the C and the deflection which is make on your the mirror arrangement, if that is your the theta, then for the theta angle the couple produced is your the C theta. This C theta is the total couple produced due to the restoring, BINA the total torque produced due to your the deflecting. So BINA is equals to your the C theta. We are interested to find what amount of current is flowing, means for the I, this I is equals to your the C theta by BNA. That implies I is equals to your the K theta. You see, C is the couple per unit twist, which depends upon the nature of the suspension wire. The nature of the suspension wire is the phosphorus bronze. So due to its the own character, it has its the constant value. So C is the constant. B is your the magnetic induction. The magnetic induction which is produces due to the using of that magnet, the magnet which we already use, that has its the magnetic induction, that is also its the constant. N is the number of turns. The coil which we have taken inside that one, that has its the fixed number of the turns, because by using once it cannot be becomes your the more or the less. So that is your the constant. A means the area of a cross section of the each turn. So each turn must have your the same area, because there is no change in its the number, means if the number to be changed, there is a chance of the increasing its the area. If the number to be the less, then there is a chance of the decreasing of the area. Though the number is remains constant, the area is remaining constant. So I is equals to the K theta, where K is equals to C by BNA. So this implies I proportional to your the theta. So I means your the current, theta means your the deflection. So on this mirror arrangement, if the deflection will show you more, then we will say that more current is there. If the more less currents or less deflection is there, then the less current is the flowing. So this I is proportional to your the C theta. Now by controlling the factor of your the K, we can control your the value of your the I. If the I to be your the increased, means the C, B, N, A, that factors to be your the changed. Therefore, if your B to be your the increase, B to be your the increase, then I to be your the decrease, N to be your the increase, the I to be your the decrease, A to be your the increase, I to be your the decrease. If C to be your the more, means the couple per unit twist, if it is made of the very thin material, means it's the couple will be the more. If the C will be the more, then your the I will be the more. So by controlling C, B, N, A, means by controlling the K, we can make your the controlling of your the I. So this is your the current. I is equals to your the K theta. If the current is there, it must have its the sensitivity. It must have its the sensitivity. That sensitivity, how it depends, we will discuss now. As per our discussion, we came to know that I is equals to K theta, means I proportional to your the theta. I means not myself or not your bow, that I is your the current. current is proportional to your the theta, theta is the deflection, I is the current which is flowing through your the galvanometer. If the deflection will be the more, then your the current factor is more, that is your the common case we came to know. So, now we will going to discuss about its the sensitivity. The sensitivity of the galvanometer is of your the two types. Sensitivity means it is a sensation. Sensation means how it responds. If the galvanometer is responds very quickly, then we will say that it has its the more sensation. If it is the response is the less, then that is called your the less sensation. So, that sensation is also depends upon the different factors, by using which the sensation is your the increase or your the decrease. So, next we are going to find the sensitivity. It is of the two types. One is the current sensitivity, one is your the voltage sensitivity. So, current sensitivity, if the sensitivity is the S, for the current you will take your the I, then this is the SI, and voltage sensitivity, sensitivity is the S, voltage is your the V, then that is called your the voltage sensitivity. So, if we will go for the current sensitivity, it is the ratio of your the theta with your the I, means it is the ratio of the deflection with your the amount of the current which is flowing. Sensitivity of current is equals to the theta by I, very simple to remember, theta by I. So, this theta by I means you see I is equals to your the k theta. So, theta is equals to your the I by k. So, theta is equals to your the I by k by your the I is cancel, that is your the 1 by k. So, what is the k? You see C by BNA we have taken as your the k. This is your the C by BNA, k is equals to C by BNA, that is equals to your the BNA by your the C. Just you discuss. SI is equals to CBNA by C, means the sensitivity depends upon B directly, depends upon the number of turns directly, depends upon the area of the turn is directly, and depends inversely with its the couple per unit twist. As I said that if the couple per unit twist is the very small, means if it is made of the very thin, then if this value to be or the decrease, C value to be or the decrease, means the sensation will be or the more. Therefore, the suspension wire which we have taken, that is made of your the very thin material which is the phosphorus bronze, and if we increase the B means magnetic field strength, if the more strength of the magnet being the taken, then its the sensitivity will be the more. If the number of turns to be the more, then the sensitivity will be the more. If the area to be the more, the sensitivity is the more. So, that is the current sensitivity. If we go for the voltage sensitivity, so sensitivity is the S, V is the voltage, on the same way it is the theta by your the V. For the voltage theta by V, for the current theta by I. If just you remember the formula, according to that you can write it in the words. So, voltage sensitivity is defined as the ratio of angle of deflection with your the voltage produced. So, that theta V is equals to your the V is equals to your the Rajaswa Nirikhyaka. You know from your the my name previous law. V is equals to your the Rajaswa Nirikhyaka. Rajaswa Nirikhyaka means in ODIA, that is we are saying that is your the RI. So, V is equals to your the RI or your the IR. So, this theta is equals to how much? I by your the k by your the IR. Now, see your the II is cancelled. So, this k will comes downward. So, 1 by your the KR is equals to 1 by k. So, here 1 by k is equals to this one, means this one. So, 1 by k is equals to BNA by C, again R is there. So, that is equals to your the BNA by your the CR. So, this is your the sensitivity, means voltage sensitivity. So, if the sensitivity we came to know, another thing is this instrument is used for your the small amount of the current. So, now the question comes, if the same thing can it be used for your the larger amount of the current? For that one we have to make the conversion of your the galvanometer into your the voltmeter and your the ammeter. So the first one is your the conversion of MCG to ammeter. The MCG means the small amount of the current. By using the same MCG, how will you make your the more amount of the current? So for that conversion means we have to change it. The basic one will remain same, but the function to be your the change. Suppose myself is doing your the some role. So myself is the, my name is what you know very well. Myself is myself, but when the role I have to make, that according to that one I have to make the role, but the my name never to be the change. Similarly, the galvanometer is there, but it to be converted to your the ammeter. So when the ammeter means it is used for your the large current. So the current to be the large means through which the current to be measured, that must have your the low resistance. If the large current is there, then the resistance should be your the low. Resistance should low. LOW low. So when the resistance will be low, the current to be your the more. Therefore, if we have a galvanometer, we want to make it to your the ammeter. To that galvanometer, we have to use a resistor which is of the resistance value is your the very small. The resistance value very small is known as your the shunt resistance. S means your the shunt resistance. If through a galvanometer, a low resistance is connected in your the parallel, then if the current is coming here the I, through the galvanometer the current is going here the Ig, and through your the shunt the current is going here the I minus of your the Ig. So though it is connected with your the galvanometer in the parallel, both must have your the same voltage. Means the voltage of a galvanometer and the voltage of the shunt, that must be your the same. So voltage of the galvanometer and the voltage of the these two be your the same. Voltage means how much? V is equals to the IR. I is equals to your the Ig, and the resistance is your the G for your the Vg. For the Vs means for the shunt, the current is your the I minus Ig, and the shunt resistance is equals to your the S. So S is equals to your the Ig by I minus Ig into capital G. So by using this formula, if we control the value of the S, then your the galvanometer to be converted to your the ammeter. Similarly, we will go for the conversion of MCG to voltmeter. If we will remember clearly about your the galvanometer to your the ammeter means low resistance connected in parallel, this total one will become your the ammeter, and with the appliance, suppose we have your the some appliance here. This is your the appliance, APPLIANCE. Through this appliance, it must be connected in your the series. And for your the voltmeter, just it's the reverse one. Means the low resistance to be replaced by your the high resistance. Instead of using in your the parallel, you have to use in your the series. Means if this is your the galvanometer, you have to take in a resistance. That resistance is here, and that to be connected in your the series. Here we have taken in the parallel, here we have to take in the series. If this resistance is the R, through the galvanometer, it to be connected in your the series. Then this total one will become your the voltmeter. You see on the diagram, this is for your the conversion of the galvanometer into your the ammeter, and this is for your the voltmeter. The galvanometer and your the low high resistance, they to be connected in your the series, and this total one will become your the voltmeter, and that to be connected in parallel with your the appliance. this is your the appliance, with the appliance that to be connected in your the parallel. So, the galvanometer now converted to the ammeter, galvanometer now converted to your the voltmeter. If you remember this one, just this is its the opposite. If you remember this one, this is its the opposite. So, this is the way how the galvanometer is converted to your the ammeter. Thank you very much.